Pluto had it coming from the beginning. Pluto's orbit crosses that of another planet. Pluto, the enigmatic small planet at the outer reaches of our solar system, is stirring up excitement in the world of astronomy. Recent reports hint at a possible encounter with Neptune, raising concerns among scientists and space fans. Notable figures like Neil deGrasse Tyson and Michio Kaku have sounded alarms about the implications of this cosmic event. But how did Pluto end up on a collision course with its neighboring planet, and what could this celestial clash mean for life on Earth? Join us as we unravel how something massive just collided with Neptune and how scientists have been left worried by this cosmic anomaly. Pluto, once hailed as a full-fledged planet, underwent a transformation in its status, being reclassified as a dwarf planet due to its peculiar orbit. Despite this demotion, Pluto still captivates and intrigues the astronomical community. Recent predictions from esteemed scientists like Neil deGrasse Tyson and Michio Kaku have raised concerns about Pluto's trajectory potentially intersecting with Neptune's, hinting at a looming threat of collision between the two celestial bodies which could have significant repercussions for Earth. Pluto's journey around the Sun stands out due to its unique characteristics within our solar system. Its orbit is exceptionally lengthy, spanning a staggering 248 years. Since its discovery in 1930, Pluto has yet to complete a full revolution around the Sun. Adding to its mystique is the highly elongated shape of its orbit, a departure from the more circular paths followed by the major planets. Furthermore, Pluto's orbit deviates by 17 degrees from the ecliptic plane, giving its path a steeper incline compared to other planets. The combination of Pluto's inclination and its elliptical orbit introduces layers of complexity to its orbital pattern. One notable aspect is its periodic intersection with Neptune's orbit. For around 20 years during each orbit, Pluto ventures closer to the Sun than Neptune, defying expectations based on their respective positions in the solar system. Delving deeper into Pluto's orbit, it's fascinating to note that it's not a perfect circle but rather an elongated ellipse resembling more of an oval shape. This unique orbit results in significant variations in Pluto's distance from the Sun throughout its journey. At its closest approach, Pluto comes within about 30 astronomical units of the Sun, while at its farthest point, it reaches over 49 Australian dollars away, almost twice the distance of Neptune from the Sun. Moreover, Pluto's orbit is inclined at an angle relative to the orbits of the major planets in our solar system. This inclination not only contributes to the complexity of its orbit but also plays a crucial role in its interactions with other celestial bodies, particularly Neptune. When Pluto crosses paths with Neptune, their gravitational tugs influence each other, altering their trajectories over time. The intricate dance between Pluto and Neptune underscores the dynamic nature of our solar system. While Pluto was once considered a lone wanderer in the outer reaches, its close encounters with Neptune highlight the interconnectedness of celestial bodies, each exerting gravitational forces that shape the paths of others. In recent years, advancements in observational technology have allowed astronomers to track Pluto's movements with greater precision. This has led to a deeper understanding of its orbit and its potential implications for the stability of the outer solar system. While the likelihood of a direct collision between Pluto and Neptune remains low, the possibility cannot be entirely discounted, prompting continued monitoring and study by the astronomical community. Despite its diminutive size and distant location, Pluto continues to command attention and curiosity among scientists and enthusiasts alike. The question arises, why hasn't there been a crash between Pluto and Neptune? The answer lies in the pull of gravity from other planets. Astronomers began studying Pluto's path soon after finding it, and its route puzzled them. Unlike most planets that's still close to the same plane as they orbit the Sun, called the ecliptic plane, Pluto stands out with its steep angle and oval-shaped orbit. The mystery deepened when they realized Pluto's path crossed Neptune's. Despite these complexities, Pluto's orbit remains stable, showcasing the intricate mechanics of space. Understanding how three celestial bodies move and interact gravitationally, like Pluto, Neptune, and the Sun, is a big challenge. It's like trying to predict where they'll go based on where they start and how they pull on each other. For Pluto, this challenge reveals how its path, Neptune's path, and the Sun's pull all work together. Terms like azimuthal libration, latitude libration, and the K oscillation helps scientists solve this cosmic puzzle. Azimuthal libration is crucial for keeping planets in their orbits. When Pluto crosses Neptune's path, it's at least 90 degrees away, keeping them from crashing. Latitude libration ensures that when Pluto nears Neptune or other big planets, it's well above their path, reducing the chance of a collision. The K oscillation, named after scientists Yasuhide Kawaguchi and Michael Efroimsky, explains why Pluto's orbit seems strange but stays steady over time. Despite the chaos in space, even though space seems random, some patterns and rules keep things in order. These rules keep Pluto's orbit stable, preventing crashes with Neptune or changes in its path. The idea of orbital chaos, showing how a celestial body's path is very sensitive to where it starts, is well illustrated by Pluto. Even small changes in its position or speed can mess up its orbit over a long time. Scientists use computer simulations to figure out how Pluto moves in space. These simulations use fancy maths to copy how Pluto interacts with other space stuff like Neptune. By tweaking these simulations just a bit, astronomers can see how tiny changes can change Pluto's path. In the late 1980s, these simulations found something interesting about Pluto's orbit. Even though there are things that should make it stable, Pluto's orbit can still be unpredictable. Just a tiny difference in where Pluto starts or how fast it's going can make big changes over many years. But even with all this chaos, Pluto's orbit stays stable for a super long time, like billions of years. This suggests that even though Pluto looks all over the place, its journey around the Sun follows some sort of order. Predicting what'll happen with planets like Pluto, which have wonky orbits, is hard. These systems are so unpredictable that it's tough to get yes what will happen in the long run. Simulations help us get an idea of what might happen, but they also show us that we can't predict everything perfectly. These models need exact starting points, and they simulate complicated stuff. Even a tiny mistake can lead to totally different results, which makes it hard to make accurate predictions. Understanding Pluto's orbit is important, especially when we think about whether it might crash into Neptune in the future. This knowledge helps us understand better how our solar system works. Pluto's orbit shows us how orbits that seem wobbly can balance out because of gravity and how things move in space. It's important to keep watching and studying these things so we can understand where we fit in the universe. When we explore space, we find out that things can be unpredictable, and Pluto's orbit is a great example of that unpredictability. Pluto's orbit is not like those of the other planets. It's more oval-shaped, which means it's not a perfect circle. Sometimes it even gets closer to the Sun than Neptune does. This can make things tricky, because Neptune is also out there cruising along its path. There's a small chance that Pluto and Neptune could bump into each other at some point. Despite its odd orbit, Pluto manages to keep its distance from Neptune most of the time. This is because of something called gravitational forces. Gravity is like an invisible force that pulls things toward each other. So even though Pluto and Neptune might seem like they're on a crash course, their orbits are carefully choreographed and guided by the pull of gravity. Pluto's orbit teaches us that space is full of surprises. What seems chaotic at first glance can be a delicate balance of forces. By studying Pluto's orbit, scientists gain insights into the intricate mechanics of our solar system. This ongoing observation and analysis are essential for expanding our knowledge of the universe and our place within it. Imagine if Pluto and Neptune did collide. It would be a cosmic event, sending shock waves through our understanding of the solar system. While we've made progress in understanding space, Pluto's situation shows that we still have a lot to learn. Studying how big planets affect Pluto's path gives us important clues about how our whole solar system works. It shows us that where each planet is and how it moves can change the paths of other things in space. Even though space is complicated, some top scientists are worried that Pluto might crash into Neptune. This makes them wonder why this might happen even though it seems unlikely. Neil deGrasse Tyson, a famous space scientist, has some interesting ideas about Pluto. He thinks that reclassifying Pluto as a dwarf planet, not a big one like Earth, is a step forward. He believes we're always learning new things about how things move in space. Tyson sees Pluto's weird path as a sign that there's still a lot we don't know. He thinks that the mysteries of space are what makes studying it so exciting. He also knows that big events in space, like Pluto's reclassification, get people interested in astronomy. Tyson wants to help people understand the cool and sometimes weird things about how space works. He thinks it's important to talk about how space mechanics can surprise us. Tyson works with other scientists to warn people about the possible dangers of Pluto's strange path. After studying Pluto a lot, he's worried that it might crash into Neptune one day. He says this could cause big problems for our whole solar system. A crash between Pluto and Neptune would be a rare and serious event. It would release a lot of energy and could break apart Pluto. Pieces from the crash could fly around space and hit other planets and moons. Neptune might also feel the impact and change how it moves. Renowned theoretical physicist Michio Kaku, known for his innovative thinking about the cosmos, offers a fascinating perspective on Pluto and Neptune's orbits. He highlights the crucial role of orbital resonance in averting a potential collision between these celestial bodies. Kaku explains that orbital resonance creates a harmonic relationship between their orbits, ensuring that Pluto and Neptune always maintain a safe distance from each other. However, he cautions that this delicate balance is susceptible to disruptions from other gravitational influences within our solar system. Drawing from historical examples of orbital changes, Kaku emphasizes the need for continuous monitoring and understanding of these intricate gravitational interactions. His insights underscore the dynamic and interconnected nature of our solar system, where even slight shifts can have profound consequences. Kaku envisions a future where humanity's exploration and understanding of celestial mechanics will enable us to better predict and navigate these cosmic challenges, ensuring the stability and safety of our solar system. In conclusion, the intricate dance of Pluto and Neptune's orbits within the vast expanse of our solar system highlights the dynamic interplay of celestial bodies. While the likelihood of a direct collision remains low due to the gravitational harmonies at play, the possibility cannot be entirely dismissed. Esteemed scientists like Neil deGrasse Tyson and Michio Kaku stress the importance of ongoing observation and analysis to understand these complex gravitational interactions. Their insights remind us that the cosmos, while governed by predictable forces, holds many mysteries yet to be uncovered. The study of Pluto's unique orbit and its relationship with Neptune serves as a testament to the ever-evolving nature of astronomical science, urging us to remain vigilant and curious about the wonders of our universe. From the outset, Pluto seemed destined for controversy. Its orbit intersects with that of Neptune, making it an anomaly in our solar system. Recently, the astronomical community has been buzzing with reports suggesting a potential encounter between Pluto and Neptune, raising alarms among scientists and space enthusiasts. Prominent figures such as Neil deGrasse Tyson and Michio Kaku have expressed concerns about this cosmic event. How did Pluto end up on this precarious path, and what might a collision with Neptune mean for our solar system and life on Earth? Let's delve into the details of this celestial phenomenon and understand why scientists are apprehensive about a possible Pluto-Neptune collision. Pluto, once celebrated as the ninth planet, was reclassified as a dwarf planet due to its unusual orbit. Despite this demotion, Pluto remains a subject of fascination. Predictions by scientists like Neil deGrasse Tyson and Michio Kaku suggest that Pluto's trajectory might intersect with Neptune's orbit, hinting at the potential for a collision, a scenario that could have significant implications for Earth. Pluto's orbit is distinct in many ways. It takes 248 years to complete a single orbit around the Sun, and since its discovery in 1930, it hasn't yet made a full revolution. Pluto's orbit is not a perfect circle but an elongated ellipse, causing its distance from the Sun to vary greatly from 30 astronomical units at its closest to over 49 Australian dollars at its farthest. Additionally, Pluto's orbit is inclined by 17 degrees relative to the ecliptic plane, making its path steeper compared to the orbits of other planets. This inclination and its elliptical shape add layers of complexity to its orbital dynamics, particularly its interactions with Neptune. For about 20 years in each orbit, Pluto ventures closer to the Sun than Neptune, challenging traditional models of planetary positions. The unique characteristics of Pluto's orbit lead to significant variations in its distance from the Sun, contributing to its enigmatic nature. When Pluto and Neptune's paths intersect, their gravitational forces influence each other, altering their trajectories. This interaction highlights the dynamic and interconnected nature of our solar system. While the likelihood of a direct collision remains low, the possibility persists, prompting ongoing observation and study by astronomers. Despite its small size and distant location, Pluto continues to captivate scientists and enthusiasts. The question of why Pluto and Neptune haven't collided is intriguing. The answer lies in the gravitational influences of other planets. Shortly after Pluto's discovery, astronomers studied its path and found it puzzling. Unlike most planets that orbit close to the ecliptic plane, Pluto's steep angle and elongated orbit intersect with Neptune's. However, Pluto's orbit remains stable due to the intricate gravitational mechanics at play. Predicting the movements and interactions of celestial bodies like Pluto, Neptune, and the Sun is a complex task. This involves understanding concepts such as azimuthal libration, latitude libration, and the quasi-oscillation. Azimuthal libration ensures that when Pluto crosses Neptune's path, it is at least 90 degrees away, preventing collisions. Latitude libration helps keep Pluto well above Neptune's path during their closest approaches. The K-oscillation explains the peculiar yet stable nature of Pluto's orbit, maintaining order amidst the apparent chaos of space. Pluto's orbit exemplifies the concept of orbital chaos, where a celestial body's path is highly sensitive to initial conditions. Small changes in Pluto's position or velocity can significantly alter its long-term trajectory. Scientists use computer simulations to model Pluto's movements, incorporating intricate mathematical equations to mimic its interactions with Neptune and other celestial bodies. These simulations reveal that even minor adjustments can lead to vastly different outcomes over time. Despite the potential for instability, Pluto's orbit remains stable for billions of years, indicating an underlying order within the chaos. Predicting the future movements of planets with unconventional orbits like Pluto is challenging due to their inherent unpredictability. Simulations provide insights but also highlight the limitations of our predictive capabilities. Accurate modeling requires precise initial conditions, and even small errors can result in drastically different predictions.